Okay, hello everyone. This is I from pantech elearning. So my voice is clear, boys. Is my video is visible? Anyone in the chat box? Good evening, Preeti. Good evening. So anyone in the chat box? Is my voice is clear? Is my video is visible? Okay. So Kumar. Good evening. Good evening all. Rajasekhar. Very pleasant. Good evening to you. Good evening, guys. Good evening all. Danush, Vishnu, Pooja. Good evening. Good evening all. So we will wait for 1 minute and we will start the class. Okay. So there is some echo. Okay. Is it okay now? Good evening, my dear participants. Is my voice is clear now, or it is you are feeling echo? Okay, Pooja. Yes. Okay. Thanks. Okay, it's clear. Okay, guys. Let's get into today's session. Okay. So in the previous session, we saw the KEIL setup. We have shown the RCC registers, and we have shown the GPIO registers. We have developed the precise delay using the timer. And today we are going to get into the UART communication protocol, and we will develop the UART communication code. Okay. Okay. Okay, guys. We will go into the class. Okay. So we are going to see is UART communication. Okay. So first we have to know what is UART. So UART means its abbreviation is Universal Asynchronous Receiver or Transmit. Okay. So these are later replaced by USBs. So this is a key thing which is later developed as a USB. As a keep the UART as a model, and they have developed the USB. And when we come with GPS modules, Bluetooth modules, everything is communicating with the UART communication only. Okay. And this is a serial data communication. So this will transmit the data in the serial way. What does mean by serial way? So we have a serial communication and parallel communication. So the key serial communication means the bits are transferred by one after another. When it comes to parallel communication means it will transfer the bits at the same time. And the main thing is UART communicates with the only two waves. Okay. So it is UART. When you come with USART, it is synchronous and asynchronous receiver transmitter. So it will have a third pin which is as a for clock pulse wave. Okay. So next. So next. So only the two UARTs can communicate with each other directly. Okay. So now what it is going to do is the data bus will send the data parallelly to the UART, and it will convert the parallel data into a serial data, and it transfers to the second UART, and again the serial data is converted to a parallel data. Okay. So that's how the operation is going on. And we will have two pins. One is TX transmitter side and another one is receiver side. So it is an asynchronous communication when it comes with UART. When it comes with USART means it is a synchronous communication. So what is the difference between synchronous and asynchronous communication? Anyone in the chat box? Anyone know what is synchronous and asynchronous communication? Okay. So what mean by asynchronous and synchronous communication? So asynchronous communication means it will not use a clock pulse for data transmission. So when it comes to synchronous communication means it will use the clock pulse for data transmission. That is what the synchronous and asynchronous communication. Okay. Okay. So next is the UART communication will use a start bit and stop bit. It will have a start bit and stop bit. Next, we have to know what is baud rate. So this is the speed per bits per second. So if you consider 9600 means 9600 bits per second. Synchronous with, yes sir. Venugopal is correct. Varsha Venugopal is correct. Okay. So next you will see what are the things we have, how the UART works. So UART will transfer the data in a packet form. So inside the packet we will have a start bit, we will have a data frame from 8 to 8 or 9 bits of data, and we have a parity bit, and we will have a 1 or 2 stop bits. Okay. So next we are going to see is how the data transmission is working, how the UART is transmitting the data. Okay. So the first step UART do is it will transform the data bus will transfer the data in a parallel form to the UART. Then UART will add a start bit, parity bit, and stop bit and converts the UART parallel data to serial data. And it will send the data in a serial way from TX to RX. So TX means transmitter send and RX means receiver send. Okay. So at the configure baud rate. Okay, this is how the first 3 steps is going to be. Then the second UART2 will receive the data and it will discard the start bit, parity bit, and stop bit from the data frame, and then it will transfer the data frame from serial to parallel and sends to the data bus. What does the data bus means? It can be a controller, it can be a CPU or something else which is giving the data to the UART communication. Okay, which is initializing the data. So that is what data bus is. Okay. Okay. So you can now convert this masterclass into an internship. So 1 month internship on embedded systems. So this internship will elaborately gives details about the key points and the registers, and more details will be given to the internships. So internship also going to be handled by myself, Shriyari. So in internship you will have a one-to-one live with me. So you can guys, if you are trying this concept means, if you have any some bugs or if you have some any doubts related to those things means, you can interact with me lively and you can ask me questions directly and I can give you a good solution for the problems. Okay. So this fees is 1200. The discount is 509. By using this coupon ESMC1. By using this coupon you can avail this internship for 691. Okay. So guys, don't miss this internship. You will have a very much futures available. So we will see the what are the benefits of the internship. Okay. So we will have 30 days of live session. So you can access the videos for 90 days, and we are going to add lots of hands-on projects in the internship. So when you apply for the internship, you can work with the hands-on projects, so and you can get a guide from us, and you have a 30 days of downloadable presentations, and we will have as I said, we will have a one-to-one mentor live session for 6 days. We will have 6 classes. Okay. So after registering this, you will get an internship confirmation letter and the internship certificate. So internship certificate is you will get a 2. One is participation and one is for completing the course. Okay. So guys, don't miss this opportunity and grab it and upskill yourself. Okay. So lots of information is going to be provided in the internship than compared to this live. So guys, enroll for this internship and make use of this internship. Okay. So the registration fee is rupees 1200. So coupon is ESMC1. So your discount amount is 509. So the discount fees is 691. So this is the link, guys. You can use this link. The link will be provided in the descriptions. And so join for the internship as a user. Okay. So you will be able to get the lots of knowledge and the hands-on projects experience. Okay. So my dear participants, it's a like button for the Shriyari session. Okay. Okay. So you can see the chat box. There they are giving a message for you for about the internship. So guys, use this link for the chat box the link will be available in the chat box, guys. So use this link for joining the internship and enroll in the internship and get use of it. Okay. Okay. Now we will get into the class. Okay. So we are going to see the registers, UART registers. Before getting into the UART registers, we will see what are the procedures we have to do. What are the UART configurations we have to do at the first. Okay, at the instance. So first is UART configuration function. So first thing we have to enable the USART clock. Then we have to enable the GPIO. Why we are using GPIO? Because we are going to configure the USART 2. So you have to go to the pinout. So you can see the PA2 pin as a function of serial 2TX, which is the USART2, and the pin PA3 as a serial 2 of RX. So we are going to use this two pins. So and we are going to give alternate function as USART2. Okay. So guys, if this session is clear, then you can give a like for this videos. Okay. So if the concept is clear, also you can give an like or answer up in the chat box, so I can able to understand that you have been got this thing. Okay. So we will select the first. We have to enable the clock register. Then we are going to set the alternate function for PA2 and PA3. Then we have to select the set the molar register and setting the baud rate for 16 MHz. As already in a previous session, I have shown you how to configure the system clock to get the 16 MHz as a ABB1 frequency. Okay. Then you have to enable the TE and RE pins, and finally enable the UART. And if you want to give an interrupt means you can enable this interrupt pins in the control register also. Okay. So next is we need to know how to set the baud rate, right? As I said, the baud rate is a speed of the bits per second. So what is the speed? The bit is transferred. So consider I am going to transfer. I am going to set the baud rate of 9600. So to calculate this baud rate, I need a formula, right? So this is a formula. So guys, you can note it. Okay. So this is a formula. So the baud rate is equal to frequency of peak clock divided by 8 into 2 into what is the baud rate we needed. So I needed is 9600. If you need to configure the 115200 means you can use those baud rate. Okay. So I am going to configure in 9600 baud rate. So what is my peak clock? In the previous classes up, I have shown you my peak clock is 16 MHz, and I have shown you how to configure the get the 16 MHz value. Okay. So my peak clock is 16 MHz. So we are going to divide the 16 MHz by 16 into 9600 baud rate. Okay, frequency. So what is the value you are going to get? We are going to get is 104.166. After getting this value, we should not take this value as an original value, because we will have a sum of the fractional point missing. So it will be having a sum. It is somewhat equal to this value, but it is not the real value you have to set. So you have to, after getting this value, you have to go to the reference manual and go to the USART register. So in USART register, you can see the USART function description. Okay. So inside the function description, you will have a fractional baud rate generation. So go to this, and if you scroll this up, wait a second, I will show you. So if you scroll this means there will be error calculation for programmed baud rates. So you have to cross check with this thing. Okay. So what is our peak clock? We are using is 16 MHz. So it is for 8 MHz. It is for 12 MHz. So this is also for 8 MHz. It is 12. Wait. Here you can see the 16 MHz. So what is the oversampling we are using? What is mean by oversampling? So we didn't give the value to oversampling because we have kept it in the reset state. Okay. So I will show the register, okay, to you. Okay. So you can see here the oversampling. If you give the oversampling by 8 means you have to you have to change the value. You have to find the baud rate in different formula. So we are going to use it in a oversampling by 60. So we are going to check those table only. Okay. Go to the UART. Description. So we are using a 16 megahertz, right? So yeah, so 16 megahertz oversampling is by 16. So this is what our configuration is. So you can see here. Wait a second. So you can see here our value is 104.25. Wait a second. So you can see oversampling by 0. So this over 8 will be not working. So it is oversampled by 16. So 16 megahertz is our peak clock frequency. And you can see here the value which is approximately related to it, not approximately, it is somewhat, it is related to this value which is 104.1975. So this is a value you have to use. Why I have choose this value? Because we have because we got the value of 104.166. So what is the real value we have to give is 104. This is the system value. So it is the error correction. Okay, so the system will do some error correction. So we should not give this value. So we should see the error correction value and we have to give this value only. So it is 104.1975. Now we have to split it into, we have to give the value in the mantis and fraction. So the mantis part is it is before the decimal point. So this 104 is for mantis and for the fraction is 1875. So we have to convert it into we have to multiply this fraction with the 16. If you multiply it with 16 means you will get a 3 as a fraction decimal. And you have to convert this, it is in the decimal form 104. You have to convert this decimal into a hexadecimal. So if you use the calculator to convert it and if the value is 68 hexadecimal. And we have to give the baud rate as a 0 cross of 0683. So this 3 will get settled in the fraction and the 68 will get settled in the mantis. Okay. So we have chosen the baud rate as 9600. This is the formula for choosing the baud rate. Okay. Okay. So now we have seen how to set the baud rate. So next step what we have to do. So next we have to define the write function. So before defining the write function, we will send the data to the DA register and wait till the data register get accepted. So if it gets settled means the data register is empty. That means the data has been transferred. So it will wait till the data register is transmitting the data. Okay. Then print function, we are going to use the string. I will show it in while developing the code. Okay. So receive function. So we will wait till the RxN to set not empty register. So this register is set when it is not when the data is received. Then we can read the data and we can return the data. Okay. So this is a process we are going to do. Okay. So now, is this clear? If it is not clear means you can ask me in the chat box, guys. So we are going to see the registers right now. Okay. Okay. So my dear participants, just hit the like button for more likes. Okay. Now we will get into the registers. I think guys, it is clear for you. So we will get into the registers. Okay. So what is the first thing we have to do? We have to enable the clock for the timer 2. It is present in the ABB1 bus as I shown you before. Okay. So if you don't know which bus it is present means you can refer the block diagram. Okay. So what we are going to use the UART2. So it is in the 17th bit. Okay. So you can see that USART2 is in the 17th bit. You have to enable the clock for the UART2. So you will enable this. Then we will get into the timers registers. Okay. Sorry. you will get the UART registers, and we will see what are the registers are there. So first is status register. So you can see the transmit data register empty. So this is a flag this is the interrupt we are going to check whether the data is transferred to a shift register or not. Okay. So and then we have a transmission complete register, but we are not going to use this in this scenario. We will use this TXE and RXNE. So this is a bit which says the received data is ready, so we can read the data. Okay. So okay. Okay, I will zoom it. I think it is in full zoom, guys. Then we will come to the data register. So this is a data register. So this is a data register from it has bits from 0 to 8, and rest of the bits are reserved. So this is a data register used for both receiving and transmitting the data. So when in the STM32 case, we will use the same registers for transferring and receiving the data. Okay. So next is baud rate register. So we are going to set the baud rate here. So we are going to set the fraction value as 3 and Mandisa value as 68. Okay. Then we will come to the control register. So we are going to do the oversampling by 16, and we have to enable the we have an UART enable bit here in the 13th question. If you give logic 1 to this 13th bit means UART enable is UART is enabled. Okay, and you can choose what is the data of bit is going to be 8-bit long or 9-bit long. So I am going to use this 8-bit long, and we are not going to use this specific parts. Parties, no parties you are going to use. We are going to check this interrupts, whether it is received data or not. We are going to use this both the interrupts, RXNE and DXNE. And we have in control register, we will have a transmitter enable and receiver enable. Okay. So next register is CR2. So in CR2 you can select the stop bits, how many stop bits you needed. Okay. If you want, I'm going to use this only one stop bit. So I can leave it as a reset. It is in a reset state. Okay. So next is these registers are comes when we are using DMAs. All this we will see in further sessions. Now we are going to just make a communication in the UART. Okay. So that's all the registers. Okay. So we have saw the what are the registers we are having. Okay. Now we are going to develop the code. Okay. Okay. So I will open the KEIL IDE. Okay. So go to the project, new project. Okay. So go to the folder. Okay. So now we have to select the board what we are using, controller. Okay. Okay, and go to the sys core, give the core, and go to the devices and add the starter file. Okay. So the starter file is added. Now we have to create the .c file. Okay. So we will make it as okay. So first what we have to do, you have to include the library. Okay, starter file. So include so this is the series I am using. Okay. So what are the things we are going to create? What are the things we are going to do? What are the functions we are going to create? Okay. So we are going to create a system. First system clock configuration. CLK. Void. Then what we are going to create? We are going to create the write function. Okay. So void of unsigned of int of character ch, we will mention it as ch. Okay, then we are going to give a print function. So we are going to give a string. Okay, so we can, by using the write function, we will printing a character. When by using this print function, we are going to print a string. Okay, print of string. Okay, then what is the function we are going to create? We are going to create is, we have to receive the data, right? So we are going to receive and we are going to init the function. So unsigned int of receive of what? Okay, so next we have to init the function void of void. This will init the UART. Okay, so first thing we will create the system clock configuration. Okay, so with this. So as already in previous class I have explained you how to create a system clock. So it is running in a 16 megahertz. So guys, if I create those things means it will take time. So I will just make a copy of yesterday's code. Okay, so this is the system clock configuration. I have already sent this code in the chat box and WhatsApp link. Okay, WhatsApp group. So we will we have configured the system clock for 64 megahertz and the peak clock is 16 megahertz. Okay, so next function we have to write is void of init UART. Okay, so what are the things we have to do? Let's see. Oh, wait a second. Okay, first we have to enable the UART clock. Okay, we will get into the registers. Okay, now go to the RCC ABB1. ABB1, it is in the 17th bit. Okay, so UART enable is in the 17th bit. Okay, we have enabled the UART now. Then what is the next step we have to do? We have to enable the clock for GPIO. It is in the RCC AHB bus. On left shift off, which is a register, which is a bit having CC of AHB1. So you can see it is in the 0th position. Okay, so we have to send the left shift the 1 to 0th position. So 0. This will enable the GPIO port now. Then what is the next thing we have to do? We have to give the alternate function. Okay. So for alternate function, we are going to use the pin 3 and 2. Okay. So go to the GPIO. So 2 is, so we can use the lower register itself because we are going to configure as 2 and 3. So 2 is TX and 3 is RX. Okay. So we have to know what is this UART function is refers to. Okay, for that go to the GPIO function registers, alternate function, go to the alternate function and you can see AF7 is having the USART 1, 2, 3, ranging from USART 1 to 3. So we are going to configure as USART 2. So we have to go AF of 7. So AF of 7. So what is the value for AF of 7? It is 1 plus 2 plus 4. So it is 7. So we have to left shift the 7 by, we have to left shift the 7 to the 8th bit and 12th bit to configure the pins as an alternate function. Okay. So we will we will go with the GPIO is equal to what is the register we have to do? Configure alternate function of low register. So this 0 will indicates that we are configured in the low register. If you want to configure the high register bit, you have to give the 1 here instead of 0. Okay. So we have to left shift the 7 by in what are the bits we have to left shift it? What are the bits? It is 8 and 12. Okay. So we have to left shift this by 8 and 7 left shift of 12. Okay. So now we have set the alternative function. Then we have to go with the motor register. Okay. So go to the GPIO motor. A of motor. Okay. So we will see the motor register. So this is the motor register. So we are going to configure this pin 2 and 3. So what is the function we have to? We are going to use it as an alternating function. Then I have to set logic 1 in the 5th and 7th bit. Okay. So I have to send the logic 1 in the 5th and 7th bit. So we will send the logic 1. Okay. Motor of the 7th bit and 5th bit and 7th bit. Okay. So this will select the alternative function. Okay. Now we have selected the motor register. Then we have to set the baud rate, right, for 16 megahertz. So go to the BR. So which is the baud rate register. So you have to set the mantis value and fraction value. Okay. So we will simply you can directly give the value to the baud rate. Okay. So just use of okay. BR is equal to 0 cross of 0 0683. So this is the value we are going to set for obtaining the baud rate of 9600. Okay. So next step we have to enable the TE and RE. Okay. Where is this TE and RE is located? It is in the control register. Okay. So go to the control register. You can see the third bit as an TE and the receiver enablers in second bit. So you have to send the logic 1 to the second bit and logic 2 to logic 1 to the third bit. Okay. In control register. So of 2 is equal to CR. Okay. On left shift of 2 and of 3. Okay. So now we have settled the TE and RE enable. Okay. In the second and third. So we have to go here. Sorry. So next thing what we have to do, we have to enable the UART, UE, which is available in the same register. You can see the USART enabled in the 13th bit. So now we will enable this bit. Okay. So 2 is equal to CR of 1 left shift of 30. So this will enable the UART. Okay. Then finally what we have to do? We have to enable the interrupt for RXC and TXC. Okay. So we are going to go to the register. You can see the 7th bit and 5th bit. If you set the logic 1 in the 7th and 5th bit in the control register, then the status will be updated in the status register. Okay. So if you need to get an interrupt in status register means you have to enable the interrupt in the control register. Okay. So we will enable this interrupt. Okay. So you sort of two is equal to CR1 is equal to one left shift off, which is a bit we have to set. We have to set this 5th bit and 7th bit. Okay. So 5th, 7. So we have enabled the interrupt. Okay. So this is the init function. So we have created the init function. Next we will go with the write function. Okay. Okay. So this is the write function. So in write function, what we have to do? We have to first write the data to the data register. So USART of 2 of DR. This is the data register. So I am going to end it with 0 cross of FF. So this represents the last 8 bits. FF represents the last 8 bits. So it's going to AND my value with this last 8 bits and gives the value. Okay. Then what we have to do? We have to go to the status register now. So in status register, you can see the transmit data register is empty. So if this bit is set, then the data is transferred to the shift register. So we have to wait till this bit is getting set. Okay, it is in the 7th bit. Okay, so we will create a while function here. While of USART2 is equal to. So which is a bit I have to left shift of 7. Right? This is 7 is a bit as it is a 7. So then we have to check with, you have to wait till this bit is set. Okay. So this loop will run, this while will wait till the TDX is getting set. Okay. So now we have created the function for writing the data. Okay. So we will now create the print function. So if you want to give a string, if you want to print a hello world means, we will create this function. Okay. Copy this one. So what is the thing we are going to do? So check create a while of star of string. Okay. String. Then we have to write the data by adding the address. So the write of string of plus plus. Okay. So we have created the function. So this will, when you give a value in the print function, then it gets stored in this string and the address will get added while adding the index. By getting the index, it will print one by one. So this is a function of this print function. Then we have to create the receive function. So we have created the print, system clock, write and init, and now we have to create the receive function. Okay. So receive function. Then what is the thing must we have to do in the receive function? We have to create a variable which is unsigned of int of my data. Okay. So this is a variable. Then I have to wait till the RxNE bit is get set. So what is RxNE? So you can say the read data register is not empty. If this bit is set, then what it indicates is the receiver data is ready to read. So we have to wait till this, wait for this bit to get set. While of result of 2 of SR going to 100 with 1 left shift of 5 because RxNE is in the 5th bit. Okay. So I am going to wait till this bit is get set. Okay. So 0 off. Okay. Now after this bit is get set, we have to write the data. We have to read the data from the data register. So I am going to give the variable my data is equal to 2 of dr. Okay. So this will read the data from the data register 2 and store it in the my data variable. And then you have to return the my data. Okay. So now we have created the receiver function also. Then we will get into the main function. So in main of void. Okay. First what we have to do, we have to configure the system clock. Okay. So configure the system clock. Then we have to init the function. So init the UART. So this will init the UART. Then create the while of 1. Now what we are going to do is we are going to receive the character. So I am going to create a variable unsigned of int of data which is equal to receive function. Receive. So this will receive my UART's data. And I have to write it back. So I am going to give a write function. Write function of data. So this will write my function. Okay. So this is how we will develop the code. Okay. Now we will compile it. So no errors found. Okay. So we will compile this. Okay. Wait us. So I have gone to the board. Before compiling, you have to go to the output and you have to select the debugger. What is the debugger you are using? So I am using is STLM debugger. Go to the settings and reset traces 8 megahertz. Reset and run. Okay. So now I will upload the code. Okay. So now code is uploaded. Now we will get into the Arduino IDE. Okay. So guys, you can see. I will show it to you. Okay. So you can see we have a serial to TTL bus. So we will we have connected this RX and TX pin. You can see the RX and TX pin with this board in the PA of 2 and 3. So this is going to get receiver and we are going to see it in the UART in Arduino IDE. So we can Arduino IDE as an UART. So no problem. We can use the UART for seeing the output. Okay. So go and select the first you have to select the board. You can select whatever board you need. Select just T1. And the port connector is wait, I will check it. Device manager. It is in the COM3. Okay. COM3. So this is this connector. Okay, guys, you can see. So the UART is so it is receiving the data and again as per our loop. So as per our loop, it is getting printed again as the write process. Okay. So now we are going to do is we are going to print the allowable. Before that, you can use this Arduino. So we will. So this is getting the receiving the UART from the data register and again it is sending to the data register and printing it. Okay, this is how it is working. Now we will try to print the allowable. Okay. Okay. So now we will write the allowable in the series. Okay, now we will upload the code. Okay. So first compile it and upload the code. Okay. So now you can go to the serial monitor and so you can see the allowable is getting printed. Okay. So this is how the UART communication is working. If you want a new line means you can go slash and by wait I will add the slash and to it. Okay. So write off. do it. Okay. So now, alright. So you can see the hello world is printed by adding the write function to it. Okay. Write of slash. So by writing this, you can print the hello world in a by one order. Okay. So guys, I will give this code in the chat box. So it will be very much useful for you. Okay. Okay. Okay, I have given this code. So guys, go and try to practice today. So guys, you have 5 minutes. We will have a Q&A. If the coding is not understand, means you can ask the questions in the chat box, guys. So we will allocate the time for 5 minutes. Okay. So why? Because we are going to use the serial monitor. For serial monitor purpose, we are seeing the Arduino IDE. Okay. For that purpose only, we are going with Arduino IDE. The main coding will be done in the KEIL IDE only. Okay, guys. Okay. So we have to see the output, right? So for that purpose, we are using the KEIL Arduino IDE. If you want me, you can download also Terra Team for it. Terra Team or Putty, like we have serial monitors. So you can use those. Okay. I think guys clear with this code. So guys, we will end this session today. So in next session we are going to see what is I2C and we are going to do a communication with it. Okay. Okay guys. So thank you. So yes, I will say the guys to share the code in the WhatsApp group. No problem. I think I have already shared it in the WhatsApp group. I will check it again. Okay. 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 Thank you guys. So guys, okay, okay, okay. I have given you a code, so you can try those things. Because it is in the loop, right? So here is it is in the loop, so it is in the while loop, so it is printing continuously. If you mention this print above the while loop, means you will be getting only one hello world. Okay. So the coding part is okay. The Snega said the coding is not clear and it is not displayed. Okay, Snega, you go and try this coding and try to see with the match with the reference manual and try to write a code by yourself. And when it comes to the Sunday hackathon 1-to-1 live, you can use this those class for interacting with me and you can ask the questions there. Okay. And if it is possible, then Saturday I will reteach this code. Okay, from first. Okay, guys. So no issues with it. Okay, thank you, Ashwati, thank you. Okay, okay, I will say them to share it again. Okay, so guys, thank you guys. Okay, thank you so much. Thank you. So you will end the